Today, we're jumping into one of the biggest challenges in modern medicine, breast cancer screening. And we're going to explore how researchers are training AI to see things that, honestly, even the human eye can sometimes miss.
Just to give you a sense of the scale we're talking about, look at this number. In 2020 alone, 2.3 million women across the globe were diagnosed with breast cancer. It's the most common cancer in the world, which makes finding it early, well, it's everything. Now, for decades, we've relied on mammograms as our best line of defense. But here's the thing, they're not perfect. There's this hidden challenge that can make reading them incredibly tough, almost like trying to find something white in the middle of a snowstorm. Okay, let's dive into exactly what that means.
That challenge has a name, mammographic density. And really, if you understand this one concept, you'll understand why this new research is such a potential game changer. So what is it? Well, to put it simply, breasts are made up of a mix of fatty tissue and dense tissue. On a mammogram, fatty tissue shows up dark, so it's pretty easy to see through. But dense tissue, it shows up as white. And what's the problem with that? Well, tumors also show up as white. So trying to find the tiny white tumor hidden inside a patch of white, dense tissue is, you guessed it, like trying to spot a polar bear in a blizzard. Doctors call this the masking effect, and it is a massive problem.
And this slide really lays out the double whammy here. See, on the left, a non-dense breast is darker, clearer, much easier for a radiologist to read. But on the right, that dense breast tissue acts like camouflage. But it's not just about hiding things, and this is crucial. Women with dense breasts actually have a 4 to 6 times higher risk of developing breast cancer in the first place.
And, this issue doesn't affect everyone equally. The research we're looking at today specifically points out that Asian women, including the Malaysian population they studied, have a higher genetic likelihood of having dense breasts. So for them, finding a way to see through that blizzard isn't just important, it's absolutely critical.
Okay, so if the human eye struggles with the blizzard, what if we could teach a machine to see the patterns that we can't? This is exactly where the research brings in a really powerful new tool. We hear the term machine learning all the time, but what is it really? It's a type of AI where instead of giving a computer a strict set of rules to follow, you just give it a ton of data, like thousands of patient records and mammogram images, and you let it teach itself. It starts to find tiny patterns and connections on its own, learning to tell the difference between what's normal and what might be a problem. The researchers were smart about this. They took a two-pronged approach. First, they trained what you could call a smart screener, an AI designed to estimate a patient's risk just by looking at their basic records. Then they trained an expert eye to do the really tough job, to look directly at the mammogram images and see right through all that dense tissue. Let's start with that first test, the smart screener. The idea here was to create a really simple but really effective first line of defense. And the goal was pretty brilliant. Could an AI come up with a reliable risk score using only the basic info that's collected when a patient registers at a clinic? Think about that. No expensive scans, no invasive tests, just data that's already there. If that worked, it could be a total game changer for helping clinics prioritize who needs attention first. So, what did the AI actually learn? Well, it zeroed in on a few key factors. It figured out that a woman's age, her BMI, and her menopause status were all highly predictive of risk. It was finding these powerful clues hidden in a basic patient profile without ever even seeing a mammogram. Now, the researchers didn't just try one AI model and call it a day. They tested 8 different ones against each other, and one came out on top, a model called K-nearest neighbor. This just proves that not all AI is created equal. Finding the right tool for the right job is absolutely key. So, the smart screener was a big success. But what about that bigger challenge? Could you actually teach an AI to read the mammograms and see through the blizzard itself? This was, the main event. It's one thing to predict risk from data on a spreadsheet. It's a whole other ballgame to interpret a complex medical image, especially one where the very thing you're looking for is camouflaged. This was all about giving the AI a true expert eye. To do this, they used a really clever technique called ensemble transfer learning. The easiest way to think about it is like this. Instead of relying on one single radiologist, you put together a committee of experts. Each AI model in the ensemble has been pre-trained and has its own unique perspective. By making them work together and vote on a diagnosis, their final combined judgment is way more accurate than any single one of them could be alone. So did it work? Oh yeah.
The results were fantastic. The AI committee performed really well, not just on the easy-to-read, non-dense images, but also on the really challenging dense ones. It actually learned how to see through that blizzard, which directly tackles the masking effect that can make things so hard for human radiologists.
Okay, so let's put it all together. We've got a smart screener that can assess risk using basic patient data, and we've got an expert eye that can read the most difficult images. What does all of this actually mean for the future of breast cancer screening? And this is so important to remember. This is not about replacing doctors. It's about giving them a powerful new partner. Think of it as a tireless assistant that can provide a reliable second opinion, help sift through thousands of scans to prioritize the most urgent cases, and ultimately just boost the accuracy of the whole process. It's a tool to make our amazing healthcare professionals even better at what they do.
And you don't have to take my word for it. The author of the thesis sums it up perfectly right here. This research shines a light on the incredible potential of machine learning, not just for finding cancer that's already there, but for actually estimating risk and predicting problems earlier than we ever could before. The research is promising, and the potential is crystal clear. So the question really isn't if this technology can help, but when. With a tool that can help us see through the blizzard and catch this disease earlier, how long will it be before an AI partner is just a standard part of every screening for every woman? Something to think about. That's all for this explainer. Thanks for joining me.